Hi everyone, I'm making this video to talk more about growth in tech careers. Salaries in tech, especially in India, are very diverse. Just on entry level alone, you have companies that pay like 2 lakhs per annum, and at the same time, you have companies that pay like 40 lakhs, even in a bad market. So, a gap of 20x. And this gap only becomes wider and wider with more experience, especially if you're not growing in your role. And what's the then way to move up in this ladder and bridge this gap? The only way to do that is by building the right skills and capabilities. Hi, I'm Anshuman Singh, and I'm making this video to deep dive into what it takes for you to grow in your career. I also then want to take you through the Scalar curriculum to talk more about how the curriculum actually bridges the gap that I'm talking about. I believe the Scalar curriculum is one of the most comprehensive curriculum for your path, but then I'll also show you that. I'm assuming here that you are currently a engineering manager. If that assumption is not true, then look at the links in the description below. Based on every persona, there's a different link. Please go to the link corresponding to your persona. However, if you stay back, then I'm going to assume that you are an engineering manager. And if you're an engineering manager, your target is, hey, look, I mean, I want to move to engineering management positions at better companies. Um, One other thing to keep in mind is that like all engineering management positions in different companies do require prior people management experience. So if you're currently an IC, moving to an EM role becomes hard, and in fact, it's very very hard. If you're currently already a manager, then moving to again a people management role is easier. Um, Now, to explain that transition and like what helps with the transition in some top product companies, I would want to talk about both. One is like what would your interview process look like? What does work look like? But before I get deeper into, hey, look, here are the kind of rounds you would go through. First, I want to talk about why do people fail frequently in EM rounds. Firstly, for engineering managers, the first level of filtration is your resume, and that is where the biggest amount of filtration happens. And one of the core reasons is like the kind of work that you've done, especially the fact that you're a people manager. What is the size of the team you were managing? What was the kind of impact that your team was driving, etc., etc., does not come out fully in the resume. In fact, one common mistake I may see some engineering managers do is they have a 3 pager, 4 pager, 5 pager resume. Nobody reads through your 3, 4, 5 pager resumes. Firstly, you have to create a 1 to 2 pager resume. You have to be really good at expressing yourself and the impact and the time, team and business size in those 1 or 2 pages. If you can't do that, that itself is a red flag. So first thing is you get your resume right. um, Assuming you've got your resume right, so which is you move to the interview stage, there then we see maximum amount of rejection happen because for some reason some managers assume that engineering management is only about people management. Look, lot of top companies, they believe you cannot be a good manager if you were not a good engineer before. You need not have been a rock star engineer, but if you do not understand coding properly, if you're not hands on yourself, then you cannot actually either command respect or actually manage a team effectively. Hence, engineering managers are also evaluated on their hands on skills. And one of the ways to do that is DSA rounds. And that is where we see the maximum amount of rejection happen. For some reason, um, engineering managers give up on coding the moment they start managing teams. Sure, at work, you might not code as much. In fact, you might be coding zero amount of time. However, you're still expected to review code very often and keep coding time to time on the side. And hence, like that hands-on is expected with engineering managers. And this is, by the way, across all levels. So whether you're in EM1, EM2, a director of engineer or a senior director of engineer or a VP of engineering, all across levels, you're expected to be hands-on. The However, the difficulty level of the questions is extremely easy, or an easy level. I mean, nobody is going to expect you to solve extremely hard questions or even medium level questions. So you're going to be tested on easy questions. However, you're expected to be hands-on. That is where most rejections tend to happen. Second is, and this is a kind of rejection that we see a lot in people who come from service companies. um, a lot of managers are not able to quantify how they would measure the productivity of their team or the impact driven from the team and whether the team was efficient or not. Did I really need a 15 people or 20 people team to actually deliver the outcome? Could I have done in a smaller team size? Can I talk about the designs of the products I have in a lot of detail? Why those choices were made, what could have been done differently? That is again another place where people tend to fail very often. And the third place where most number of people fail is the system design phase. You're asked to design systems, you're given a case study, and the expectation is that at your level, because you already have decent amount of experience, you're going to be taking a bunch of design decisions for the team. Hence, you have to be strong on system design. So if somebody tells you, hey, look, how would you go about designing Hotstar, then you're able to drive the discussion with the interviewer on what exactly within Hotstar. And when we do reach the component, then are you able to come up with the right choices or not? Are you able to explain things very well or not on the pros and cons of the approaches that you've taken? That's where the maximum amount of failure also happens. Now, I've talked about the failures that happen in interview. Let me also actually go over the actual interview rounds that happen and then the work, which would also give you a fair idea of what the process looks like. So, on the interview side, there are typically probably one round, maximum two rounds on DSA. However, if you don't do well on those, you might still be rejected. So, hence, important to be hands on with coding, important to have some amount of practice on DSA, includes all topics of DSA, including DP and graph as well, but easy problems there. You will have, however, multiple rounds on people management. um, these are questions like, hey, look, what was the size of the team that you were managing? Have you managed or have you fired people from your team? How did you manage low performers in the team? Show us examples of how were you able to move, let's say, certain low performers to high performer or like maybe medium performer range. um, how would you measure effectiveness of the team? Did you hire the team or did you inherit the team? What was your hiring strategy? um, so bunch of things around people management, which is just to gauge whether you are an effective people manager or not. Uh, your policies, your answers sort of tell me what are your key objectives when you're managing your team, right? And that basically has to align with what the company is looking for. Then the second kind of rounds that you have is around system design. This is where a lot of focus is on architectural system design, which is HLD. Um, on schema design, API design, you're expected to be good. On basic design patterns, so nobody expects you to just have knowledge of extremely complex code design patterns or class design patterns, but like basic design patterns. Understanding again, because HLD is important, so again understanding whether I need a monolith or a microservices, and within microservices what are the design patterns. What is the Saga design pattern, what is the circuit breaker pattern, what is sidecar, and a bunch of other things. That is still expected of you. And a basic again knowledge of a framework. Now you could have any tech stack, but in that tech stack, like what's the framework? How does, let's say, databases work there? How do frameworks work there? So for example, one MVC framework is Spring Boot if you're a Java coder, so knowledge of that. Another round that you would have is the product vision round or a program management round. Again, this depends on what company you're interviewing at. um, for example, Amazon or Facebook, they typically do a product vision round where they try to probably talk about a product, discuss with you what kind of objectives should this team have. If you agree on a 6 month objective, then what is the path to achieving that objective? So what are the, if you have to then assign work to pods or maybe smaller team leads, then what is, how would you distribute the work, what would their targets look like, how are you enabling them, etc., etc., which is in a way a mix of project management plus your product management, in some ways, in how you decide about like what the team's target should be. There's one round on that. Again, summarizing: DSA round, people management round, system design round, and product and program management round. You have those rounds broadly as an engineering manager. In all of these rounds, however, one of the other things that is being evaluated in parallel is, would you be a good cultural fit for the company or not? That is extremely, extremely important in your role. If you don't fit well culturally, then there is going to be problem. Um, at work, again, whatever happens in the interview, all of that is important. You have to be a good people manager, good at system design. You have to be good at product and program management. You have to be a little bit hands on as well. However, another thing that is expected of you is you're able to drive the team towards learning new tech as and when required. You're able to help the team or push the team towards directions where they also keep upskilling themselves or keep becoming better, so that if there are ways of maybe making your product better, they understand how to make the product better. They're also exploring things on the outside. When issues happen, then again the team is capable of troubleshooting the issues. In a way, if the team is not there, then you're also there to maybe help troubleshoot the issue. You're at least that comfortable with your systems. You understand the right practices with code, which is, does my system have the right kind of observability? Does it have the right kind of alarms, right kind of metric measurement, right kind of logging? If I need to do distributed tracing, then do I have that? Do I have the right software practices around, let's say, CI/CD pipelines? Do my builds get auto tested or not? Do I have proper staging environments or not? And basic familiarity with cloud, right? So that you know that, fine, I do have people who take care of the cloud, but then, like, if there are practices there, are those taken care of or not? So those become important at work from the tech standpoint. From a non-tech standpoint, I mean, again, your focus on impact, being able to actually prioritize what to do versus what not to do, how to prioritize work, how to help your team become more and more productive, how to help manage performance, how to manage stakeholders, so that other teams are aware of what you're building. So in case, let's say, your stuff could be reused by other teams, then they're able to reuse your stuff, right? Increases the impact of your team. So being able to do all of that also is important for work. Combination of these two makes you very effective then at your role. And to be honest, like what I described was probably the job of an EM too. As you increase your scope of work, which is now you start managing managers and maybe a level above, then you start moving up the road to a director, senior director, VP, etc., etc., right? um, However, the basics remain the same. Essentially, it's all about how do you increase the impact as an engineering manager. Now, while all of this is great, how do you get started by learning some basics here? So, what I'm going to do is I'm going to walk you through the curriculum to show you what could you do if you're an engineering manager. How do you get started with learning here? It involves some bit of one-on-one coaching plus some bit of learning on things which you could learn. So, I'll describe both of those. Okay, so the curriculum at Scalar is broken down into three parts. I mean, there is a backend track, there is a full stack track, there's a data engineering track. For the time being, I would stick to the backend track, um, given it's about a management position. I mean, however, you could refer to any of the tracks. I would just maybe focus on which are the modules that are super, super important for you. Um, and maybe for the remaining modules, you could choose to do those modules or you could choose to skip it. You would still get the written notes of those modules with you. You would still have the assignments with you. And if you ask for my recommendation, I would say, I mean, do everything, because in a way it helps you build uh, a proficiency on those modules as well, which will only be useful. However, if you're short on time, if you're in a rush, maybe you could do the most important modules first and then you can go to the remaining modules at some point of time later, assuming that you already have a decent amount of understanding of engineering and you're already good on certain topics. All right, so without further ado, let me actually begin with the explanation of how the curriculum is structured. The first module is DSA. Again, very comprehensive with respect to topics. Every single topic is here, and if you do this, I don't believe that you probably need to look at any other module or any other resource for DSA. One of the things I would do say here is that it is possible that because you will not face medium and hard questions in DSA, even if you solve a few questions in assignment after every class, you're still fine. Every class is, however, going to be followed by a few assignments and a few homework problems, which are essentially problems, DSA problems, very similar to interview problems, that are based on the topic that was taught in the class. Now, this helps you with all the DSA rounds that you're going to face in the interview. But more importantly, one of the things where I feel DSA helps is that if you've done a lot of practice, then your coding accuracy increases, which means if you ever build anything, your productivity is going to be higher because you not make bugs. Two is, in whatever you think, efficiency almost becomes a habit. You cringe at build writing an inefficient solution. So that is another reason why I feel like DSA is helpful. Three is, large scale systems and the design of those systems is anyhow an important skill that you'll need to have. All large scale systems, if you look under the hood, they are utilizing some or the other form of DSA. For example, all relational DBs, they are stored on B plus trees. Um, a bunch of things they would use like a LRU cache beneath. All of those DSA. So hence, I mean, understanding DSA makes understanding of those systems also easier. One of the things I'm assuming is that given you're already in the management layer, engineering management layer, you already know some bit of coding, right? So in a way, you don't have to be taught basic coding. However, if you were somebody who is a beginner, does not even know coding, then we also have a beginner section where prior to DSA, there is a 2 months of just teaching you language. Post DSA. Now DSA is mandatory for you. Post DSA, there is relational databases and SQL. And here, there's a high likelihood that you might already have done these topics. However, I'll still call out these topics. You learn schema design here, which is mandatory for you. You learn about indexing and transactions and isolation levels here, which is somewhat mandatory for you. You learn how to write SQL queries here. It's a great skill to have for an engineering manager, because for some of the analysis that you might want to do, unless you have a big analytics team already, it makes doing those analysis much easier for you. Hence, a good skill to have. If, however, you know most of this module already, then you can skip the module, ask for notes, and go over the notes and then like do the assignments. This is if this module is happening to you after on or after May of 15th, 2024. Now, why is this important? Firstly, schema design questions in the interviews. You might, in some off cases, be asked to write a SQL query, but this is, I mean, a rare case. You might not be asked to write SQL query, or like maybe you might not be even asked questions around indexing and transactions in the interviews. However, important for jobs. And as I said, like, schema design is something which is going to make your life easier if you have designed the schema really well for your software. Um, SQL skills, they help with analysis, basic analysis that you probably don't need to disturb your team for. You can do it yourself. Now you might ask, oh wait, this is relational DB. Why not NoSQL DB? I mean, NoSQL DB is covered in later modules. We'll come to that. Again, one more thing to note here is every single class here is also followed by assignments. Some assignments are where you have to write a SQL query. There are some other which might have MCQs. There are some, for example, for schema design, you're given use cases and you have to actually put in your design. That what table would you have? What columns would you have? What is the relationship between these two tables or entities? And our system gives you a score, which is, I mean, as of today, AI driven. And you also get, by the way, scores from your peers once you submit your schema design. Post that, there is basic project, which for an EM position I would say you should skip. It is anyhow optional. um, this is again with the assumption that you have built some project in the past. um, what basically it covers is how do you get started with building a project, how do you get started with basics of cloud, how do you get started with Git, how do you get started with like basic things like inheritance, authentication, um, schema versioning, REST APIs. And I mean, we for a basic MVC framework, I mean, we refer to Spring Boot, Java Spring Boot, but again, like you could use any other framework. In those cases, we actually give you a recording and few other resources. One thing to keep in mind here is one of the philosophies we operate with is that while we help you with all of these resources, one thing which we will always push you for is important to build depth in the tech stack that you have used in the past. However, be open to using new tech stacks, be open to exploring new tech stacks, because when a problem is thrown at you at work, you should choose the tech stack for the problem based on what is the best tech stack for the problem, right? Like, it should not be chosen because you know a particular tech stack and you don't know the other tech stacks. Hence, as an EM, even more important, be flexible with tech stack, not just the tech stack that you know of. Anyway, project, I would recommend. I mean, I'm sure you would have done projects in the past, hence you could probably skip. However, let's say if there are few topics here and there that you find interesting. For example, if I say, hey, wait, let me look at like what is covered in pagination, searching, sorting, you could skip the module and you'll anyhow get the typed notes, recordings, and you can do the assignments. So if it is just one or two classes, you don't need to do the entire module for that. Post that, there is advanced project module. Sorry, advanced language module. This is where we cover the basic of OOPS, basics of multi-threading, and basics. I mean, and then the advanced concepts within Java. This is a good to have for you. If you could go through this, awesome. If you already know it, then you could skip. However, if at all, I mean, there are questions on, I mean, if Java is your language, I'm assuming, then I mean, if there are questions on Java streams, Lambda collections, it gets covered here. If there are questions on multi-threading, concurrency, gets covered here. If there are questions on OOPS, it gets covered here. Um, if imagine you're not a Java coder, again, while I said like you should be language agnostic, if you're not a Java coder, you would rather code in Python, then we have very similar resources for Python as well, where you get type notes, you get recordings, you get assignments. You could do those in Python as well. Chances are you might also know of these concepts from before. If you do, then you can skip this module. Post that, you have the design pattern module, low level design pattern module. This is where you learn about class design patterns, how to structure your code, solid, etc. Right? And this is something you might get questioned on. So this is an important module for you. Those designs are then followed by machine coding rounds, right? In case somebody wants to test, can you quickly create a project, which is less likely, but still good to have hands-on experience on. Then you do the machine coding projects. Now, hence, all kind of interviews which would have design pattern questions or machine coding rounds, they you get comfortable with those in this module. Again, anything another thing to notice: every class will be followed by an assignment. Some of those are MCQs, some of those are scenario based, some of those would require you to implement a feature, and we would then check whether you implemented it correctly or not using unit test cases. The module after that, this is an interesting module, and I think the next two modules are the most important module for you. The first one is the advanced software engineering concepts. This is nothing but utilizing some of the components which you are most likely to use in your day-to-day work. So, for example, how do you create microservices? And then how do you work across microservices? Um, if you're building an event-driven architecture, then how do you use, let's say, a messaging queue? How do you use Elasticsearch, which is a full text search engine, right? Like in case, let's say, you have to index documents and search through them. For example, let's say you're indexing resumes. How do you search through resumes now? You use something like an Elasticsearch, right? So getting hands-on with some of these tools which you are most likely to use in the future, Elasticsearch, Kafka, um, understanding computer networks, basics of system design, microservices. Within microservices, again, distributed tracing, Spring Cloud, logging, monitoring, containerization, especially with Docker. Some of those, which is more likely to use it at work. I mean, that gets covered here. It will also prep you up for the next module, which is system design. Um, Again, all of these classes also have assignments where you have to implement something, unit test cases, and that's how we see whether you have done your job properly or not. Then the next module is system design, and probably this is the most important module for you because this is where you'll get most of your questions in your system design rounds. Here again, first we work on the building blocks: consistent hashing, caching, CDNs, master slave, multi master, cap theorem, etc., etc. NoSQL databases, and then we go over the architecture of these things, and then we start to get into case studies. For example, how would you then implement a Google search type ahead, or a Messenger, or an Elasticsearch, or Zookeeper and Kafka? How would they work internally? If I was implementing a Zomato or Swiggy or a Google Maps, how would I go about implementing that? How about Uber? How about, let's say, Hotstar? Maybe even smaller questions like how would you implement, let's say, a rate limiting system? How would you implement a distributed ID generator? All of that is covered here in the form of discussions. Um, and these are very relevant for all form of system design rounds that you'll have. Not only that, I mean, if you have developed a good understanding here, it is going to also help in your team discussions, in case, let's say, there are discussions around how to improve the existing design, or if you're designing a new system from scratch. Post that, if you're an engineering manager, I mean, there is one more elective. Actually, there are a couple of electives. I'll tell you like what I believe. There's an elective which is called product management for engineers. This is extremely important for you. This maps one on one with the round that you'll have on product road mapping, and how to plan that roadmap. What should be your product vision, and then how to plan that roadmap. It maps very directly to that, so hence extremely important for you. If you're interested, then I would also suggest that you should do the data engineering elective, because it makes you familiar with how data engineering systems work. Did not go in a lot of depth, but that understanding helps, because you might work with data engineering teams, in whichever company you go to, and that with that understanding you'll be able to then have proper conversations with those teams instead of feeling lost. Few more things. So apart from hard skills, Scalar also does soft skill classes, and you also have a one-on-one mentor. One-on-one mentor is supposed to be more senior than you and also coming from a management background. um, in a way, things that you need to get better at. Your resume has to look good. If you remember, I said like that is one of the most common reasons for failure. You have to be very good at time management. You have to be very good at communicating, and you have to be very good at people management, and you could be asked questions there. I'll start from the last one on people management, because you're going to be asked questions there. To be honest, there is no one formula fits all. So hence it is best driven through a one-on-one mentor. You will be given a one-on-one mentor at Scalar. You'll actually get to choose one one-on-one mentor at Scalar. You should ensure that time to time you're scheduling discussions with them, discussing your current work, and asking them to ask you these hard questions, evaluating your response, and maybe understanding how you could improve in your current work. Also, how do you improve your presentation of the previous work? Second part is your communication, resume building, and time management. Now, around all of those three, we do a soft skill classes to actually like tell you the principles of how do you do these well, checklist items that you should keep in mind. Some of these are augmented with the mentor as well. For example, a mentor would then help you review your resume once you have gone through the class, implemented those suggestions, and tell you like maybe where are still the holes, and maybe how can you present again your experience better. Sometimes people are not very comfortable talking a lot about themselves, so mentors are able to then poke and get that out of you. On communication, again, like career classes will lay out the foundation, but how you then implement it, whether you're actually effectively implementing it or not, are you getting better at communication, that again a single one-on-one mentor would be able to solve. So that those are things you should utilize your mentors for, which you'd also get at Scalar, plus your career classes, soft skill classes. One more thing to keep in mind is, look, I mean, you're not paying, or you're not just, if you enroll at Scalar, you're not just paying Scalar for the content. Most probably, if you do a lot of research, you'll find somewhere in some books, on some website. You're also, in a way, I mean, the one value prop of Scalar is that there is an ecosystem that exists, and through that ecosystem you benefit, because your chances of completing the program, effectively absorbing what is there, increases multiple times, as compared to a recorded course. For example, for the same duration, our completion rates are like 100 times better. If you want to know more detail about that, what that is, and how am I quoting those numbers, there's a link in the description of the video. You can go and watch that. But let me describe the ecosystem, right? Firstly, you're not learning alone. You would have other engineering managers with you, you would have other senior tech folks with you, and you would also have junior folks with you. There is some customization, some different form of routes for all of them, but again, in a way, you're learning in a community, and hence you benefit from the community, right? Not just for jobs, but also for the fact that they're also solving problems with you. You in a way get inspired. There's a healthy competition. And second thing that happens is, because of that, every day after a class there is assignment, and people start discussing assignment in the WhatsApp group that you're part of. It, in a way, you start then living and breathing the entire program, and it hence again becomes easier for you to stay consistent through the program. Two is their live classes. They happen at scheduled times, so it enforces a schedule. Every week you have something or the other happening, so again, harder to give up. With live classes, you also get to interact with the teacher and ask them questions in case something doesn't make sense. Third thing, you have one-on-one mentor, and I just described to you why the one-on-one mentor is very, very important. You also have TAs, so when you're solving assignments, which are there after every class, if you get stuck, then the TAs can help unblock you instead of having to waste a lot of time there. Um, and as I described, like, you still have the peer community, you have our support, um, with anything and everything that you need. Now, I mean, that is with respect to Scalar. But I mean, with or without Scalar, this happens to be the path that you should follow. Um, if you join Scalar, then I'll see you some at some point of time in some of these classes. I wish you all the best. Thank you.